Okay, so we're going to do more mathematics in Python, and the first thing that we're going to do actually is just copy all of our mathematics in Python and stick it down here. And we're going to just look at additions, and why we're copying all of the above, just for some little extra pieces. And in particular, when we're using integers here. So A is an integer, it's of value 10, and B is an integer and it's of value 20. We can see that they're integers because when we hover over them, we can see that it's a variable literal type 10 there, and the same thing for B. And when we hover over R, we can see that it's also variable literal of 20. Now we can print here the type is, and what do we get when we type of R? So what do we get when we add A and B? So we're adding an integer and an integer. We are going to get back an integer, hopefully. So when we run our little piece of code here, and I'll actually remove this first one because we don't need this anymore. So we're just looking at the types now. We get the type is class integer, so we add an integer plus an integer and we get a type integer. And likewise for the subtraction, and this is a nice thing about Python, it just does everything for us out of the box. We get the difference, and then we get the type is, and then again we get a class of integer. And when we do a multiplication of two integers, and we run this piece of code again, we get the type is class integer. And finally, if we do a division of integers, what are we going to get back? So we just copy this piece of code again, copy and paste, and run this piece of code, and we get a floating point number that comes back. And the reason we get a floating point number that comes back is that 10 divided by 20 is a half, and a half is, it's got a decimal point in here, and so the Python interpreter reads that as a floating point number. Now we can look into this a bit more, or maybe we can adjust the numbers a little bit and see what else happens. So for example, let's create a case where we've got 20 divided by 10, so that our division will evaluate to a 2 rather than to a half, and what will come out of the Python interpreter here, and we still get a class of floats. So what we are actually seeing, and I might actually just switch this one back, so 10 and 20, and just further down below I'll put a second division in here, which is exactly the same division, but this time we're going to overwrite the A and B is equal to, instead of having 10 and 20, we're going to do it the other way around, so 20 comma 10, and we were expecting to get back an integer of value 2, but we don't. So when a division occurs in Python, we get back a class float, even though we were expecting to get an integer back. So this is just how the interpreter works in Python. And just one last portion, which is a division by 0. That's going to be a problem in nearly every programming language and on any calculator that you ever have. So we have division by 0. So how we create this division by 0? Quite easily. We will take the same set of variables over there, and we will turn b into the value of 0 because we're going to do a divided by b. So let's copy all of this down below, and when we try to run it, we are going to get thrown an error message, and the error message is a 0 division error, and it says it right here and says division by 0, and we get pointed out which line the error message happens to be on, which is line number 34, with a nice big arrow pointing towards it saying r equals a divided by b, which is what we can't do in Python. Python doesn't allow for this. And I might just introduce something new, which is the try except block, where we can try this entire statement here, or at least we can try this part. So cut that out of there and paste this into the try except block. So cut that here and paste that into the try except block. We have to do some indentation, which we will talk about in Python. And here we won't use a pass, but we'll print some sort of error message. So we do except exception as E, and we print you cannot divide by 0. And we will even print out our error message over here, E. So this is exactly the same as what we had before, but in a try except block, so that we don't break our code and don't have this 0 division error. Instead, we will get a nice clean printed message. So we will treat ourselves gracefully. And when we run that code, we get you cannot divide by 0, 0 division error. So that is a more advanced version of mathematics in Python, although we were just looking at the types that were created and the 0 division in Python and the divisions which give us floating point numbers back.